Okay, chapter 2D will be on the Zener diode. Zener diode is, we have calculations for the Zener diode. Okay, in the test normally for chapter 2, question for chapter 1 and 2, it is either circuit with diodes ataupun circuit with Zener diode. Okay, so if you want to study, it is two main area tu lah. KVL, KCL involved with diodes ataupun Zener diode for chapter 2. For chapter 1, it can be on Thevenin's, on the parallel series resistor, KVL, KCL, yang tu. Okay, alright. For the Zener diode, I hope that you guys dah faham betul-betul on the diode, normal diode biasa. Okay, for the normal diode, normal diode, the symbol is like this. Okay, and then the normal diode can conduct current only in one direction. Okay, for forward bias. Okay, what will happen in reverse bias? Okay, I equals to 0 lah. Yes, open circuit, so cannot be operated. Okay, but then if we have the Zener diode, it can be in both direction. Zener diode, the symbol is dia macam tu sikit. Nanti lagi kita tengok on the symbol, dia lain sikit lah for the Zener diode. Okay, and then last time I did explain on this IV characteristic kan. This is I, this is V. Okay, this is for forward bias. Yang belakang here is for reverse bias. Okay, for the Zener diode, it is actually to be operated for this area. Okay, for reverse bias. Okay, where for the, if we use the normal diode, it cannot be used. Okay, the diode can be damaged. So we use the reverse bias. We use the Zener diode. Okay, and if you tengok Zener diode IV characteristic, I hope that saya ada lukis hari tu. This one here is 6.3 volt. Okay, meaning that this is the safety voltage to be operated for a certain ataupun for the commonly used Zener diode. Okay, so it is actually negative lah, because this one is in negative side kan. Okay, so negative value. Okay, normal diode will be permanently damaged if we have a large reverse current. So tak boleh guna lah. Okay, for the Zener diode, it can be used, but then only until certain value. Sampai satu point dia tetap akan damage juga. Bukannya dia boleh operate sampai minus 100 watt ke, no. Until one point, it still can be damaged. So for the Zener diode calculations, dia boleh tanya if this value of supply, what will happen to the Zener diode? It is either safe or not safe to be operated. Kalau not safe, maksudnya the diode can be damaged lah. Okay, so tak boleh pakai. And how to get the Zener diode? It is actually depends on the doping process. Doping process is what? Betul lah tu semua tu. Saya dengar sik-sik, intrinsic doping. Boleh lah tu. Hopefully you guys still remember on that. Okay, so how to get the Zener diode? It is actually there is a process lah in the doping process. From the intrinsic, we add dopant, we put it either element P or N. Okay, terpulang. Let's say kalau if you want to get the Zener diode, the ratio is like this. Okay, so we have to follow on the ratio lah. Okay, dia ada on certain amount lah. Okay, so this is comes from the P and N combinations. Kalau untuk, let's say if you want to get the normal diode, the ratio is certain amount. If you want to get the Zener diode, ratio dia lain. Okay, and for normal diode in rectifier, for Zener diode in voltage regulator. Okay, for the applications lah. Right. Okay, this one explanation dia juga. Okay, so this is the IV characteristic yang saya lukis tadi. Okay, for IV characteristic, this is for VZ if ideally minus 6.3, tapi dia tak not all the time minus 6.3 lah. It is ideal value, so depends on the value that on the certain circuit. Okay, so this is for the Zener breakdown and avalanche breakdown. Okay, for first one, we go for the Zener breakdown. Okay, heavily doping of the Zener diode causes the device to have much narrow depletion layer. Okay, kita nak tengok. Okay, specifically this one is for Zener breakdown. Okay, in the breakdown region is dekat sini. Okay, this is the area for breakdown region. Okay, this one can be either 0.3 or 0.7. Okay, depends. If it is silicon, 0.3. If it is germanium, 0.3. Silicon, 0. Yes. Okay. Okay, for the Zener breakdown, this one is explanations on the electrons lah, the movements of the electrons and holes of the carrier. Okay, remember this is in the breakdown region and we are dealing with the reverse current. Okay, ni tak ada apa. Alright, so dia ada dua, avalanche breakdown and the Zener breakdown. The first dia akan jumpa is Zener breakdown. Kecil Okay, Zener breakdown is due to the movements of the ions. Okay, dekat dalam reverse, if we have, this is PN junction. Kat tengah tu apa? Here is P, here is N. This one is depletion region. Okay, so if in reverse bias, depletion region will be besar ke kecil? Besar, yes. Okay, so in Zener breakdown, let's say if this is for Zener breakdown, size dia banyak ni. Okay, for avalanche breakdown, it will be wider because for the Zener is due to movements of the ions, because we have P dengan N, different concentration of the majority carrier, so dia akan beralih lah positive and negative ions tu. So we have these movements of the ions, so we can get the Zener breakdown. Okay, what can happen further if we increase the voltage ataupun the I, the current, dia akan jadi further breakdown lagi. Sebab kita akan pergi lagi, it's like kalau sini dah reverse bias, nak reverse lagi reverse. Okay, so dia lagi further breakdown, so we call it as the avalanche breakdown. For the avalanche breakdown, this one is due to the collisions of the ions. Kalau tadi ions dah bergerak, bila dia makin bergerak, okay, excited of the ions, dia bergerak movements, so dia akan jadi collisions. So this one is due to the collisions. So bila dia bergerak baru ada collisions, kan? Bila makin berlanggar, dia lagi banyak akan collisions. So that is why the movements of the ion first for the Zener, only then due to the collisions of the ions. Ions yang bergerak tadi. Dia tak berlanggar dulu baru dia bergerak. Faham tak? Okay. Alright, so this one is dia sebenarnya dia tak adalah fixed value sangat, it's just on the reference lah. Okay, larger value than -5, maksudnya it is further. If here is 5, so dia akan lagi further reverse, okay, on the region. Okay, so this one is the Zener diode punya symbol in the circuit. Okay, and we have for the Zener we can replace ataupun represent with the VZ. VZ is the voltage at the diode of the Zener. Okay, we call it as the VZ lah, macam ni. Okay, VZ. Kalau VD, diode, normal diode. Okay, VZ is the Zener diode. Okay, this one is explanations of the avalanche. Apa kat sini, electrons in the kinetic energy. Okay, avalanche. So dia punya collisions lah due to the kinetic energy. So bila dia lagi berlanggar, so dia akan langgar sebelah, dia akan langgar. Like kita main kereta langgar-langgar tu. Okay, it's like that lah. Konsep dia lebih kurang macam tu. Okay, this one saya terpaksa pergi a bit laju because we need to go for the calculations part for this 2D. Okay, for further explanations, kalau you rasa ada few slides yang saya tak explain detail, you can go for the recording. Okay, recording yang previous, bukan this recording. Alright. Okay, so this is for avalanche breakdown. This is Zener. Okay, kita tengok Zener dulu. This one is Zener. For the depletion region, like I've mentioned, mesti ada depletion region because this one is the reverse bias condition. Okay, this is for avalanche breakdown. The region is wider, okay, due to the collisions of the ions. Ada kinetic energy, baru ada collision semua. Okay, this one you guys boleh baca details, and ini pun explanation dia. If you get the notes without these explanations, I think this one saya macam baru tambah. Okay, tapi you can read further lah on this explanation. Okay, for this one, voltage regulations dah ada pun in the slides, voltage regulator kan. Okay, so this is the Zener diode applications in the voltage regulator. Okay, for the Zener diode, the circuit is actually simply like this. We have this one, we have the RS. This is the Zener diode, and then we have one load resistor. Okay, so this is the same circuit. Ini adalah V in ataupun VS, V in. VS lah. Supply, the supply voltage. This is the RS, this is VZ, and then this is VL. So from the concept of parallel components, so for here VZ and VL sama kan? Because we have the same node. Here is one node. Let's say we have A. So here we have B. So VZ is from point A to B. VL is also from point L. So from point A to B. So it is from the concept lah. Alright. Okay, this one is on the voltage regulator. Okay, as for here, this is to get the percentage efficiency of the voltage regulator. Okay, we no load. This one is, since here we have the load resistor. So for the load resistor, it can be minimum value until maximum value kan. Okay, variable resistor. Okay, sebab yang ni dia ada simbol macam tu, meaning that it is variable resistor. So it can be from the lowest value minimum until the maximum. Okay, so for here, for we no load, it is at the minimum value. Okay, and then with full load is the maximum over the maximum value. This is all of that darab dengan 100 to get the voltage regulator efficiency percentage dia. Okay, we no load is voltage at the no load when there is little or no current to flow. For full load is at the maximum value of the load resistor. Okay. Okay, Zener diode is a diode that allows current to flow not only from its anode to cathode, meaning that positive to negative. Anode is positive, cathode is negative kan, for the normal diode. But then also in the reverse direction. Maksudnya bila we want to the diode to be operated from positive to negative pun dia boleh. For the Zener diode only. Normal diode no. Normal diode only one direction. Okay. Alright, so a Zener diode is used to operate in the reverse region and maintain constant output regardless the variation current. Okay, so that is why we use dekat dalam voltage regulator. Voltage regulator is the end in the block diagram yang paling hujung before kita dapat the DC signal kan. Okay, so contohnya kalau if we have one adapter, so yang paling hujung before kita sambung to the devices kita. What will happen kalau the diode in the voltage regulator tu rosak? So it might damage our devices. Sebab tu yang paling hujung tu kita mesti ada the Zener diode. It kind of protection jugalah. Okay. Tapi biasalah, sometimes ada juga benda ni rosak juga. Alright. Tapi that is why as an engineer it is very important for you untuk betul-betul carefully design the system, nak pakai what value so that dia boleh selamat untuk operate. Salam. Okay. Alright. So now we go for the calculation. Okay. For the test, normally untuk Zener diode ni, kalau ada soalan on the Zener diode, jawapan pula, markah dia will be 10 marks. So banyak lah. 10 marks. Dia bukannya 2 markah, 3 markah on the calculation. So it will be around 10 marks lah for the Zener diode. Okay. So for the calculations, the circuit is simple like this. For the circuit, this is the supply connect with one resistor. We have the Zener diode. We have the one load resistor. Okay, this simple circuit. But then we have three conditions. We have three conditions for the Zener diode circuit. Okay, the first one is both the voltage supply and the load resistor is fixed, meaning that only one value. Okay, dia tak ada min and max, fixed value. The second is we can vary on the supply. It can be V in max, VS lah. Sometimes kita pakai VS senang sikit. VS min. Because we vary kan. So it can be minimum and maximum. Sorry. This is yang ketiga. Sorry. This one is the third one kan. Vary, supply, fixed on the load. The third case. The second case, RL min, RL max. Okay, and then for the R and V, kita ada current kan. The other components ataupun the other parameters that we might relate in the circuit. So if satu ada min max, so the current pun boleh ada min and max. Okay, depends on the relationship dia nanti. Okay. Alright, so for here also we can relate with the power. Okay, so you can use this formula P equals to IV. Okay, normally ada juga soalan where it is given the value of the power. So you can use the value given to get it is either I ataupun V lah, depends on the question. Okay, and yang kat sini if one of the dibagi P max, maksudnya the I is the I max lah. Okay, if it is given P min, so the I is the I min. Okay. Alright, so we go for the first condition. Both is fixed. Okay, this one is a bit simple. Kita ada dua-dua fixed. So we have one supply, one resistor, one diode and a load resistor. So at each of the IR is dekat sini, yang lalu on the R resistor. IZ is the current that flow in the diodes, the Zener diode, and IL is the current yang lalu in the RL. Okay, so kalau kita buat the KCL, IR equals to I, yes, IZ plus IL. Okay. Tapi first thing is we need to determine the diode is on ataupun off. Okay, so this one is diode to off. Sebab tu kat sini tak ada kan. So it is open circuit here. Okay. So determine the state of the Zener diode by removing it from network. Okay, and then to determine the diode is, the first is kita remove dulu, lepas tu kita nak kira. This is the steps dia lah. Okay, we need to measure the value of the VL kat sini. This is VL. This one we use the voltage divider rule. RL over R total multiply with the voltage supply. Okay. So, we consider macam there is nothing in here because we want to get the value of the VL. Normally VZ is given. Normally in the question VZ is given because we want to compare. Okay, so dia akan bagi VZ. Kalau dia tak bagi VZ, dia akan bagi information lain. Okay. Alright. So now, if once we get the value of VL, what we need to compare is if it is greater than VZ given in the circuit. Normally kalau macam ni kan dia akan tulis lah VZ equals to 8 contohnya. Okay, if it is given Zener diode is on kalau the VL is greater than VZ, because sebenarnya kat sini kan it is in parallel. Betul tak? Since it is in parallel, sepatutnya value dia kena sama. Okay, but now kita kena determine dulu. So kita tak boleh nak simply okay memang akan on. So we need to determine. There is also question yang saja dia nak buat trick. Okay, so you need to determine first. Okay, so this one, if we get it is greater than VZ, the value of the diodes, so it is on. If it is less than VZ, the diode is off. If the second case, kalau diode to off like this one, so IR is equals to IL. Normally question dia suruh cari IR. So if it is off, terus tak ada, so you dapat this one. Okay, macam mana nak kira? Just buat KVL, normal KVL biasa je lah, kan? Okay, sebab dia akan jadi series lah, one simple series circuit. Okay, so if it is on, so we need to solve lah, since the diode tu ada. So we need to solve by using this one yang biasa, IR equals to IZ plus IL. Okay, IL when it is on, we consider as the value VL. Okay, we use the value of the VL yang kita dapat tadi, this one lah. Okay, from this voltage divider. So that is, first is, once we tadi dah dapat VL, voltage divider, so we can get the IL. Okay, IL is in here. So once you dapat the IL, we can get the IR. IR here is VI, here is V. Let's say kalau here is VL, sini VL, sini pun VL lah kan? Sebab the same point, same node, here is the same node. So kalau here is VL, here is also the value of VL. That is how we get the VR, VI minus VL. V dekat sebelum dia, VI, this one, minus here, because we want to get the VR. Okay, VR equals to VI minus VL. V sebelum tolak V yang selepas, to get the current at the, the voltage at the resistor. Okay, and then to get the to get the current, so just bahagi this one I V over R lah, over the resistor R. So we get the value of the IR dekat sini. Just now we get the value of IL, now we get the value of IR. Next, if we want to get the value of IZ, you can use this KCL. Okay, and sometimes dia ada bagi juga, kalau dia bagi P, so you can use the P to get the V ataupun the Z juga. Ataupun if the question suruh cari P, then you darab je lah V and the Z. Okay. Okay, so we have one question here. Okay, first we need to determine the diode condition, on or off. Okay, untuk buat tu, so we apply this one. Kita tukar value. You tengok the cara kerja. We just change the value. Let's say here we put 10, 1K we put 2K, 1.2 kita jadikan 0.5. I'm not sure jawapan dia berapa. Okay, we have this one. Sinilah, saya letak sini. 16 jadi 10 watts, 1K jadi 2K. This one 0.5. Okay, so first we need to determine the Zener diode is on or off. So we need to get the VL kan, equals to RL 0.5K over 2.5K kan. Ni RL plus R. R total lah. Okay. RL over R total. Multiply with, formula dia sebenarnya RL over R total multiply with the voltage supply. Okay, multiply with the 10. What is the value? Sama ke? This one 2 watt. Okay, for 2 watt it is less than 10 kan? VL less than VZ, so it will be off. Sama pula. Okay, sama off pula. Okay, so this is how to determine lah. So once it is off, so kita boleh terus cari the other yang lain lah. IR equals to IL. So you boleh perform the KVL biasa kan. So here for this one, if we do the KVL, minus 10 plus 2 KI plus 0.5 KI equals to 0. So you can get the I here. I equals to IL equals to IR. Okay, simple. So now this is because IZ is 0. Because IZ is 0. Now kita nak cuba buat if IZ ada value. If that one, yang ni dia naikkan, sorry. Okay, so we need to try change the RL. So the RL, let's say kalau buat 4K, harap-harap ada value. We try to change the RL to 4K. Yang lain tu maintain. Cuba buat yang ni. This one 4 over 4K over 4K plus 2K multiply with 10. Berapa? 6? Tak cukup juga. Dia kena more than the VZ. VZ kita 10. So tak boleh. Letak 8 terus. Okay, the 4K you 4 tak boleh, dah tukar 8. Yang lain faham tak? Kenapa kita tukar-tukar ni? Berapa? 8. Susahnya nak naik ni. 13 point? Okay. So kalau if we change this one, the RL we change to 8K, we get 13.33 watt. Is it? Okay. So if 13.33 meaning that okay. So now the diode, if RL equals to 8K, VL equals to 13.33 watt. Zener on. Kan? Zener on. Sorry, apa dia?
Itu kalau ada 8K kan? 8K darab dengan power supply, voltage supply. Over until 10. Macam berapa?
Oh, still 8. Habis 13 ni dari mana? If 8. Sekejap 8 over 8 plus 2K multiply 10. Yes, we want it is more than 10. Dah 10 tu jadikan 20 sudah. Okay, we increase the supply lah. Dah tak dapat sangat. Still 8. Kenapa dia tak boleh naik? Apa dia? 8K 8 over 10. 8 over 10 multiply 10. 8 over 10 multiply 10 kau dapat 8 juga. Okay. Kan, betul lah kan, betul. Okay, 10 lah. Kalau 8 tu jadikan 10. 10 over 12. 10 over 12. Okay, 11. 12. Janganlah besar sangat, nanti value dia lari sangat. Okay, 12. Kalau 12? Ya. Alah, hai. Dah balik soalan ni lah semula. Oh, because the supply dia, okay, the soalan supply dia 16, kita 10, kan? Jauh beza, betul. Okay, supply dia 16 lah. Oh, sorry, dia punya pendarab dia tu, because yang kita darab supply dia 16, kita turunkan jadi 10, jauh beza dia kan. Okay, tak apa. So change that supply jadikan 16. Okay, 16. 8 over 10 darab dengan 16, tak boleh. Okay, 20 je lah. Kalau 16. Alah, korang ni kenapa betul kata? Okay, kalau 16. Oh, okay, tu dapat. Okay. Alright. Okay, so this one 12.8. Okay, so 12.8, what is the condition here? Okay, because kita tengok balik kepada mana tadi? Here. 12.8. Okay, because the VZ is 10. VZ is 10. No, VZ kita 10. VZ 10. Cuma this one tadi kita this one kita maintain 16. The VZ given is 10. Okay, so the VZ is 10. So now we get 12. 12 is greater than 10. It is on. Okay, so once is this on, when it is on, so kita guna the value of the VZ given. Okay, when it is on, we use the value of the VZ given. Kita tak pakai dah value of the RL tadi tu, value of the VL. Okay, so when it is the Zener diode, this is the resistor given. Kalau it is given 10, then we assume parallel here is also 10. Even though when kita kira tadi tu, to determine the diode on atau off dapat lain. Why? Because dia dah bagi siap-siap in the circuit. So kita kena guna yang dia bagi. Yang cari tadi is to determine condition of the diode only. Jangan get confused kat sini. So pendek kata, bila dah on, guna value yang bagi. Okay, so once dah dapat VZ equals to VL. Kat sini pun ada tulis VZ equals to VL because it is parallel here. Okay, so dia sama point, so must be same value. So from here, V1 is the supply. 16 ni supply. Sebab dia ada kat sini kan, dia ada resistor. So here is the supply. Okay, kalau buat KVL, minus VS plus VR plus VL equals to VL atau VZ sama je, equals to 0. Okay, so now kita dah tahu yang mana kita tahu. VS given, VL given juga. We can only use the given value kalau dia on je. Okay, jangan kalau you kadang-kadang buat terus assume as on, tak kira yang tadi tu, because ada markah kat situ juga to determine the condition. Okay, and then now we want to get the VR pula, because from the VR value we can get the IR. Okay, lepas tu we can get the VR here to get the value IR. Untuk for the IL, straight away IL kat sini kan. So the IR equals to voltage bagi dengan resistor lah. Okay. And then we have this IR, we have this IL, so we can get the IZ. Okay, so kat sini IZ equals to IR minus IL. Okay. And then if the question suruh cari power, then you carilah the power. Sometimes ada juga dia bagi power, dia suruh you cari dia tak suruh cari current, tapi from the power value yang dia bagi, so you can get the current kan. Okay, sometimes kalau dia bagi, dia tulis kat sini. Okay, here contoh this one. Okay, so dia dah bagi in the question, dia bagi the power. Okay, tapi this is the power maximum. This one is the power in the Zener voltage. So since the Zener ni kan it can be operated in the reverse, so it can be at the maximum value ataupun the operating value lah, the Q point punya value. Okay, so this is the maximum, this is the value that we get. The value, if it is less than maximum, it is safe to be operated. It can be PZM ni PZ maximum lah. So if it is more than PZM, it is not safe, and then the diode can be damaged. If the question macam tu, normally you kena buat conclusion dia lah. The diode is safe to be operated. Okay, that is why value yang ni penting, because we need to determine it is either less or more than the PZM. Okay, kalau kita kira from the PZM, the value that we can get is IZM, IZ maximum dia juga. So it cannot be more than the IZM. Kalau tak, dia akan damage. Okay, meaning that dia akan further reverse bias lagi. So dia akan rosak jugalah on the diode. Okay, alright, so this is the first one. Boleh ada soalan tak on the first one ni? Simple je, tapi for the circuit you need to relate with the KCL, voltage divider, apa lagi? Kalau perlu KVL. So all that Ohm's law yang kita dah belajar dekat dalam chapter 1. Okay, alright, so boleh that one? Okay, so next one we want to go to the fixed supply and vary the resistor. Fixed supply and vary the resistor. For this fixed and vary condition number 2 and condition number 3, we assume for on condition. Okay, we assume for the diodes to be on conditions. So this one is from the voltage regulator formula juga. Voltage regulator, voltage divider, RL over R total multiply with the V supply ataupun VS, sama lah. Okay, V supply dia tu. Okay, okay, so this one is vary resistor. Bila vary, it can be R min with the R max, RL min, RL max. Okay, so bila RL we have min and max, we also can be, dia boleh ada IL min and IL max. Okay, so this is to get the RL min. V equals to, I equals to V over R. So if here is min, yang sini adalah max, betul tak? Sebab dia inversely proportional. Satu besar, bila yang bahagi akan jadi kecil. Okay, kalau yang atas IL min equals to V over RL max. So dia akan terbalik lah. Bila kita bahagi dengan yang besar, kita akan dapat the current is the small value. Okay, so for the RL min is the actually this one is come from this formula juga. So it just pusing VI minus VZ. What is VI minus VZ? V R V supply minus the Vz kan. It is the VR. Okay, so it is VR here. So this one is yang saya mention tadi on the IL max. So we use the value of RL min here. Okay. Ini this one tadi VI minus VZ to get the VR. IR is the simple Ohm's law. This is the KCL. And once we have the IL min, the resistor value, the RS ataupun we have one resistor kan, connect from the supply resistor here kan. This R is fixed. Okay, so VR is also fixed. Okay, IL min equals to IR fixed minus IZ max. IZ max is the IZ diode lah. Okay, IZ in the diode, spec of the diodes. Okay, for the RL max is equals to VZ ataupun VL. Jadi sama je. Okay, dia boleh je tukar if V equals to IR, I equals to V over R. So you nak pusing IL duduk belah side sini, R pergi bawah sini pun boleh je. Up to you lah. Okay, okay, we have one example here. Okay, kita tengok this example first. To determine the value of RL, we need the diode to be on. So we assume the diode to be on. Okay, so here, since the diode is on, so Vz is equals to VL. RL is equals to, this is from the Ohm's law, the voltage divider. This is R, VR. Okay, VR. This is R multiply with the Vz value here. This one 1K, yang ni multiply with the Vz over this is VR. R darab dengan voltage dalam Zener ataupun Vz equals to, up to you. If you want to use Vz boleh, if you want to use VL pun boleh. Okay, if you rasa macam confused, then you can use the VL. Okay, and then multiply with the voltage supply. This one is the Vz over the VR. You can get the value of the RL min. Okay, this one dah dapat lebih awal tadi lah, the VR, because kita assume to use the value of the Vz. Okay, remember once kita assume the Zener diode on, so kita guna the value of the Vz given kan. Okay, what else? And then once kita dah dapat VR, this is VI given, Vz, if it is Vz given, then you can get the VR kan. Okay, VR is because resistor, this is one point of the Vs, this is another point of the Vz ataupun VL, sama je. Okay, so you can get the value of the VR. Okay, IR pun sama, the value of the VR or divide with the resistor value. Okay, here is IL min. IL min, once kita dah dapat IR, this is resistor, this is the Zener diode. So here is the resistor kan. So this is IR, this is IL. Okay, so IZM is the maximum Zener diode current kan, yang dia bagi. IZM biasanya dia bagi PZM. Okay, this is the maximum value. So we assume this is the maximum. Kita dah ada IR, kita ambil yang maximum. So the IL is minimum lah kan. Betul tak? IR equals to, tak muat. For the KCL dekat branch tu, we have the IR equals to IZM equal plus IL plus IL. Okay, because at this branch we have IR pergi turun is IZM. The other one current that goes up is IL. Okay, IZM kita dah tahu dah maksimum, so the IL will be minimum. Let's say we have 10, so 8 dah lalu sini, so sana akan pergi 2 je. If 4 dah lalu dekat Zener, so akan tinggal lagi 6, so sini minimum, that one will be maximum. Okay, so dia akan pusing. Kalau sama-sama lah. So dia akan jadi sama lah kalau sama. Tapi kalau for this variable resistor, dia tak ada sama, so dia akan ada min and max. Okay, so this one, that is why kita ada IL min kat sini. Okay, because here kita assume kita ambil the maximum value. IZM is the maximum current can flow in the diode, so that diode tu tak rosak. If it is exceed the IZM, diode akan damage. Okay, alright, so that is why kita ada IL min. Once we get the IL min, so we can get the RL max lah, because I equals to V over R. If it is I is min, R is max, dia terbalik kan, satu besar, satu akan kecil. This one naik, this one akan turun. Okay, so here is IL min, so the R is max. Okay, the value is kat sini kita ambil from the value of the Zener tu lah. Right, so that is for RL min. RL max. Just now kita dah dapat RL min. Okay, so the condition dia actually like this lah. Okay, this one is the resistor kecil, the current will be besar. Okay, if the resistor besar, the current will be kecil. Dia terbalik. Okay, so this is the values that can be flow dekat dalam the variable resistor. Okay, for these types of question, fixed supply, vary resistor, dia jenis macam ni lah. You rasa macam banyak formula, tapi please do exercise. Once you dah do exercise, dah boleh tahu how to tackle. Yang penting is you need to understand IZM ni apa. Okay, the first step, what to do to assume what. Okay, once you dah faham what that one, and then you dah strong on the KCL, KVL, benda tu pun it is easier for you. Okay, alright, this is the second one. Let's do one example. Kita tukar this value kat sini je lah. Okay, kita tukar values. Bila tukar value dalam kelas macam ni, I'm not sure jawapan dia dapat berapa kan. On the spot, spontan je kita tukar. Okay, let's change VZ. Kita jadikan 5 tu kecil. 5 IZM, dia sebenarnya tak boleh pakai letak ni, nanti dia akan lain sebab because dia ada calculations. 32 kita jadikan 16 lah, kita make it half. I just want you guys untuk try tulis. Okay, 16 mili. Kalau VI kita maintain S50, I'm not sure dapat berapa. Okay, first thing kena kira this one. Okay, VI tu we maintain. IZM pun kita, IZM jadikan 16.
IZM 16. Kalau kat situ dah nampak IZM, mesti dia tu memang mana?
Not necessary sebenarnya. Tapi actually for second dengan third, yang very ni biasanya kita assume as on. Biasaannya lah. Okay, so kita guna value of the VZM tu. Kat dalam sini ada contoh tak? Cuba kira untuk this value, dapat tak? Oh, yang nombor 2 ni saya tak tulis pula. Kalau yang nombor 3 saya dah note down bila tukar nak tukar dia value berapa. Tak apa, cuba dulu. Dapat berapa? Dia punya RL. Banyaknya. 111. 118 point berapa? 111 111 point. Oh, all one. Macam tak jadi je ni. Tak apalah, kita cuba ya. Okay, so this is the RL. Okay, sometimes kalau you not sure it is min or max, you can tulis dulu RL. Tinggal space sikit, nanti bila dah dapat the other value, you boleh determine it is min or max. Boleh juga. Okay, so this is RL, the first RL. So next one, you can get the value of the VR kan. VR ni sebenarnya straight away daripada circuit tu dah boleh dapat dah kan. VR is 50 minus 5 je kan. 45. 50 minus 5 equals to 45. Okay, 45 volt. This is RL. So we don't know it is either min or max. Kadang-kadang boleh je macam tu, you tak tulis dulu. Tapi once you dah dapat the other lagi satu value, then you tambah lah min or max. Okay, so next one we want to get the value of IR. Straight away you boleh dapatkan juga. Resistor kita tukar tak? Okay, resistor kita jadikan 2K lah. Oh, dia effect. Oh, tak payah. Dia masuk tadi kan, so tak apa. Resistor maintain. Okay, resistor maintain je. Dia beza sikit lah, because the VR is 45. So 45 over 1K, 45 milli kan? 45 milliamp. Okay, so here pun akan jadi 45 minus IZM. To get the IZM from where? 16. From the given kan? Yes. It's like bila kita beli barang, dia ada data sheet dia, spec dia kan? Okay, so the given, the maximum value. Okay, so 45 minus 16 here. Jauh besar sangat value dia ni, saya tak tahu berapa. So IL. Now we want to get the value of IL. Tapi guys, katakanlah kalau bila keluar soalan Zener, you confuse sangat ni nak pakai the formula mana dulu, VR mesti boleh tahu sebab dah ada supply, dah ada VZ. So you kira yang tu dulu. Okay, and then dah dapat VR, you can get the IR. Okay, from the given value. Okay, so the IL mean will be 29. Okay, 29 milliampere. Apa dia? IR, how to get the IR? Kat atas tu dah ada dah. Ini 45. 45 daripada yang atas tadi. Yes, dari yang atas tadi tu. Okay, so you can get the IL. So now it is IL. Dah dapat the IL. Sama juga with the VR tadi, R tadi, RL. Kalau tak sure min or max, you boleh tinggal dulu. Tapi bila tulis tu, tinggallah space sikit. Nanti once dah dapat ada one value, you tambah je tepi dia. Okay, alright. So now you can get the RL, the other one RL pula. Sebenarnya for this type of question, kita macam backward, buat dari belakang sampai ke depan. Dia lebih kurang macam tu lah. Okay, so now is RL. 1 besarnya. 172.41. Ni 1.25K. Oh ya. VZ is, kita punya VZ, what is the value? 5 over 5 over 29 milli, 172.4 ohm. Kalau 10 over 8 milli dapat 1.25 kilo. Oh ya ke? This one?
Betul lah.
Ha.
1.25 kilo betul. 0.008.
Ha.
8 mili.
8 milli 0.008.
Bagi 29.
Bagi 0.0.
Tak.
Sampai 0.029 kan? Dapat 1
Dapat 1
Because here is kita 5 over, tapi 5 bahagi 29 mili tak dapat kilo Terus sebab 10 over 8 mili dapat kilo. Oh, okay, faham. It is actually, yang ni is 1250. Kita dapat 100. Okay. Faham. Okay, faham tak yang lain? Baguslah macam ni, kita sama-sama faham. Okay, alright. So now it is 172 ohm for the R. R tadi dapat berapa? 111. So kita tak salah, masih betul ya. 111 dengan 172. So you can terus. Okay, tadi 111, 112. So satu min, satu mat. It just value dia tak jauh beza, tapi still betul. Okay, alright. Okay, so 172. And then apa lagi yang kena buat? Habis lah kan? Oh, P. Normally P ni depends on question. Kalau question suruh tulis, dan you kira lah. Tapi for the flow, untuk kira yang lain tadi dari atas, okay, faham tak? Let's say you are not confident it is either min or max, kira dulu, continue kira dulu sampai dapat dah ada value lagi satu. Okay, so yang ni next class saya boleh guna je the value, dia tak salah pun this one actually. Kita tukar yang lain, faham tak? IR min IR minus IZM, IR minus IZM. Berapa IR min for the value dapat berapa? IR min equals to IR minus IZM. IR berapa tadi? IR 40. Betul lah tadi. Itu betul lah 29 mili. This one. Oh, this one. This step. Nampak tak ID? Okay. So, itu saja for this second case. Ada soalan tak? Ada. Okay, ada soalan tak? Dia dekat dalam note saya rasa tak ada example lain kan? Boleh tengok dekat tutorial. Soalan tak? Senang ke susah? Ni attendance. Semua dah sign ke attendance? Siapa yang baru tulis nama tu kat dalam sistem dah masuk ke tak sebenarnya? Sebab I just extract the names yesterday. Semalam petang maghrib kot saya balik sebab nak extract the attendance. Lepas tu yang mana nama tulis by hand tu maksudnya kat dalam SIMS tak ada lagi nama dia. Tapi kalau ikutkan registration untuk drop off dengan add subject dah tak ada kan? So please check your status dekat dalam, you biasa check kat mana? You future. Please check your status. Okay. So can we go to next one? Laju je. Okay. So the next condition is we vary the supply. This one we vary the supply, but then we fix on the load. Okay. Sama juga this one, we use the voltage divider. This is voltage divider formula, and this is, guys, bincang yang tadi lagi ke? Oh dah. Okay, faham dah? Okay, bagus, dia tak payah tanya saya. Okay, so this is for the third condition. The third condition is we vary the supply, meaning that it can be VI min, VI max. Okay, but then it is fixed on the load resistor. Okay, so this one is on the voltage divider. Thank you. Voltage divider formula. Oh, this one. Okay. Okay, this is for voltage divider formula, and this one is on the VI min. Sometimes kalau tak confident it is min or max, then you can simply kira dulu. Okay, once dah dapat the other value, then kita boleh tahulah it is min or max. Okay, this one steps dia macam a bit pendek sikit as compared to the second case. Okay, and here yang ini is the load resistor plus with the load. Dia terbalik for this one. From this one terbalik daripada voltage divider. Kalau voltage divider R over R total kan, so this one dia terbalik. Okay, so darab dengan VZ. VZ is the given dekat dalam the value tu. Okay, so this is IR. Since it is dia circuit dia macam ni kan, so this is the supply. So this is the Zener diode tu lah. Sorry. Okay. And this is the resistor. So we vary this one. This is vary. Since the vary, so dia akan effect the cut IR. Okay, so IR, it can be IR max and IR min. Okay. Since here is the max, so here is max. IZM is maximum value in the diode kan. Okay. So IL nak dapat dari mana? Kat sekarang ni untuk third condition ni IL dia satu je sebab dia fix. Dia vary depan, kat belakang pula dia fix. So IL equals to VL over RL. Okay. So this one yang IR max comes from this one lah. Okay. So we can get the value of IR max. So this one VI max, sekarang ni kita tahu this and we tahu this one. Why? How to get the VR max? It is I R max tu darab dengan R kan. Yang ni circuit dia kan this is the supply resistor, the Zener. This is the load resistor RL. So we vary yang ni. Kat sini dia akan ada IR min dengan max. Yang belakang ni dia fix. Here is IZM. This part is fixed. So kalau sini fix, IL fix, IZ pun fix. So yang vary is IR lah. Nampak tak? Kalau yang tadi kita fix dari depan, sebab supply kita fix. RL tu yang kita vary. That is why kita ada IL min, IL max. RL min, RL max. Kan? So now we vary VS. So current dekat Vs is IR kan? Sebab tu current yang ada min and max is IR. Boleh je kalau you nak tulis IS, tapi current yang sama. Okay, so since here this one is vary, so yang belakang ni fix, IL fix, this one is IZ ke bawah. Okay, IZ pun fix, ambil IZM. Okay, so this one lah, this is come from I yang masuk equals to I yang keluar. IR is masuk, goes in, IZ turun keluar, IL pun keluar kan. So you can get from there. IZM is normally given, yang ada M tu normally given dalam Zener diode tu. PZM, IZM, VZ. So that is value yang normally will be given. So you can use that value untuk get the IR. Once you get the IR, nak apply dia dekat mana? Get the VR. Why VR tak boleh guna Vs equals to VR plus VL? Bukan tak boleh guna. It is actually benda yang ni lah, comes from here. Tapi because this one we don't know, so we can get these two. Yang belakang tu kita boleh dapatkan. Okay, because kita vary supply kan. So the supply we don't know the exact value. Because the supply kita tak ada, we don't know the exact, it can be either min or max. Dia boleh ada dua value. Okay, that is why kita kira on the value yang belakang. So VR max is come from, we get dah ada value I, R is given, so you can get the value of VR max. VZ also given, and then kita boleh dapat VI. Okay, this one lah, IR max darab dengan R. Okay, alright. So this is VI max. Ini VI min yang tadi. Okay, for the IR min, IR max depend on the question. Kalau disuruh kira, then you kira. Or else kalau tak perlu, then tak payahlah. Okay, right, we have one example here. This one. Okay, first thing we get the VI min. Okay, we assume as it is minimum. So this RL, value of the fixed resistor, load resistor, tambah with the resistor given, and then multiply with the VZ. VZ also given. Okay, let's change the value. Okay, this one saya ada tulis, so kita boleh tengok. Sekejap saya sometimes if I spontaneously tukar the value macam ni, saya debor, takut tiba-tiba tak dapat kan. Okay, for this one, okay, this one, let's change the value of R jadi 250. This one 250, and VZ is 25. Yang lain maintain. So we just change the value 250 and 25. Yang lain maintain. So for here 1.5k plus 250 multiply with the 25 over 1.5k. This one, it is actually comes from voltage divider. Kalau kita nak cari VZ equals to VL. If you want to get the VL, RL over RL plus R multiply with the VS kan. So that is for voltage divider. Oh, lama. Sorry. This one. Actually, to get the formula for the VI min, this actually comes from the voltage divider. Voltage divider yang biasa is VL. Kita nak dapatkan the voltage at the load resistor VL. RL over RL plus R multiply with the VS. Okay.
Okay.
Okay, so what is the value here? Huh? Okay. Huh?
30.6.
Ini calculator dalam radian ke apa? Okay, so for those yang masih lagi confused on the VI mean formula. Okay, for those yang masih confused on the VI mean formula, it is actually comes from the voltage divider here. This one. Okay, comes from this red box. VL ni is the VZ lah. Okay. So dia tarik pergi sebelah sana, RL dengan R pergi tarik sini. Jadi yang ni akan over RL. Sebab tu dia over RL. VS dia jadi VI mean. Okay, it is actually voltage divider formula. Alright. So 30.1, and then next one we get the value of IL. So IL will be 20.8 milliampere. Okay, so IR max 80.83. Next one, you can get the VI max 25 45.21 volt. Okay, so yang tadi 30, just now 30, now 45. Okay, so yang 30 tadi we can call it as mean, 45 will be the maximum. Okay. Alright, any question? Ni tak ada apa dah ni sebenarnya. This one is just additional notes. This is simple exercise. This one yang tadi ada soalan tak? This one semua dapat? Senang je kan? Pasti? Satu poin dua tak tukar kan? Tak, 1.2 tak tukar. Tak, sama. We just tukar R and the VZ je. Only R and the VZ. Okay. So this is for Zener lah. 3 conditions for Zener. Yes, kalau tanya saya memang kita tunjuk agak laju lah as compared to previous semester, bila saya tunjuk on this one slow sikit. This time around saya ajar laju sikit. So kalau rasa macam agak tepu, balik tulis, tengok balik the recording. And then in the tutorial pun I think ada soalan juga. If you have anything to ask, feel free untuk WhatsApp saya anytime. If you want to discuss dalam kelas pun boleh, cuma raise up lah. Kalau student tak raise up, I don't know. Okay, I don't know yang you tak faham and then you need discussion. Alright. So this is one example, tapi this example saya dah letak siap with the solution. Okay. This is one example of question. Contoh soalan. Okay, for contoh soalan test lah. Okay guys, this is contoh soalan test. This one fixed for both I think. fixed for both the supply and the resistor. So dia boleh tanya like this lah. Okay, find for the IL, load current is the IL, and then the IT is the IR, value at the resistor tu. And then you need to relate with the IZ. So this one you need to use the KCL. And yang ni saya nak tunjuk actually. Kalau dia bagi like this, so you need to conclude it is either safe or not. So kalau let's say for the current, this one 55 ni I think dia given kat dalam circuit kan. Kat mana dia bagi tahu? Oh, okay, dia bagi tahu kat sini PZM. Okay, so if the PZM is 500, so we can get the IZM. Because dia bagi power, so you can get the current from the power kan. P equals to IV. Okay. So you can get this one. But now, from calculation, the value of IZ is 44 milli. But then, the data sheet for the Zener diode is 55 milli. So you can conclude it is safe. Because less than IZ is less than IZM. Okay. Ini contoh soalan. And then, what the question can ask is, bila kita tukar the value, it is either change the value of load resistance, change the value of RS, ataupun value R resistor tu, tukar supply value ke. And then, dia boleh suruh you kira once again, and then you need to compare. This is the new value of the IZ. Okay, this is the IZM yang given tadi. So you need to conclude. Just conclude macam ni je lah. It is greater than IZ greater than IZM. Tulis macam ni pun boleh je. Okay, and then it is not safe. Okay, maksudnya kalau guna juga, diode can be damaged lah. Alright, so this is contoh soalan test with the solution sekali dah bagi. Okay. But then this one for the first case lah, fixed for both voltage supply and the load resistor. Alright, so this